Hey everyone, welcome. Today we are going to look at the state pattern and how we can use it to clean up our code. So first of all, I have a basic 2D scene setup in which I have a character that has the animator component attached to it, and two scripts. We'll look at these later on: a rigid body and a box collider. Below the character we have a ground, which is a simple white cube with the layer ground on it, and a box collider 2D. Now the ninja character has a few animations which I have already created. It has three states: run, jump and idle. If I open the animator, you can see the default state is idle. Then we don't have any connections to run and jump since we are going to be playing them using the animator component directly. Now first of all, let's open up our script, the one that doesn't use any sort of state pattern behavior. So here is the script. It's a relatively simple script, so let me quickly go through it. First of all, we have the components that are attached to our game object, which are the rigid body and the animator. Then we have the states, since our player has three animations or three states, which is grounded, jumping and falling. For the falling state, I'm basically using the same animations as the jumping animation. We have some variables like the move speed, the jump force, how high the player can jump, and a ground check distance, which is simply a ray cast that is thrown downwards, and if it hits the ground, we say that we are grounded and we can then jump. In the awake function, we get all the components and also hash all the animations. So animator.string to hash, we'll just name these idle, run, jump. These names should be exactly similar to the ones inside our animator. And for the falling animation, we are using the jump animation. And here we attach our ground layer, which is basically the name of the layer ground. Now in the update method, we simply use the input.getAxis to check our horizontal movement, and if its value is not equal to 0, it means we are moving. And then also here we check that we should only be jumping or falling if we are not in contact with the ground. So we cast a ray in the downward direction, and we check if that ray hits something on the ground layer, it means we are grounded, and this is set to true. This is a debug.draw. It simply draws the ray cast in the scene view for us to debug. And similarly here we get the input.keycode space. It says that if we are grounded and we press the space key, that means we'll jump. And if we are jumping, then of course we are going to fall, so we are going to set is falling to true. And here we just simply use a jump start time, which is the current time in which we press the space key, and this minimum jump duration is defined over here, which is 0.2 seconds. So after 0.2 seconds, we simply say that we'll start falling. And similarly, on touching the ground, we say that we are grounded and we are not falling anymore. And for the horizontal movement, we already got the move speed using the input.get horizontal axis, and we simply apply a linear velocity in the direction we are moving. So if we press the left key, we use the flip the sprite, and we press the right key, we flip the sprite again to basically see if we are moving left and right. So as you can see, we have a lot of if else conditions here, and this code works perfectly fine. But the problem is that if we add a new state over here, then we need to change all these conditions, we need to change the if else, and we need to change a lot of stuff. We are basically breaking every rule of the solid principle if we do that. So in order to fix something like this, we use the state pattern. So let me first run this example and show you the behavior. We can move, as you can see. If I press the space key, I can jump, we fall, we move. So this is the code, and we can basically apply some form of the state pattern using enums, which is over here. So over here we define different states using boolean flags, but here we define a proper enum. We define all of our states here. Then simply we have access to the player state, and by default we are going to be in the idle state. We have those same components, same variables here, the same animations, the same minimum jump start time and the jump start time. In the awake, we cache the basic animations and all the components, and in the update we do the same thing. we check that if we are pressing any key on the horizontal axis, we get that horizontal input and we move. And similarly, we do a ground check and then a movement check. But here you can see that the code is a bit more cleaner and little bit easier to change. But here the state pattern is still not being applied. So what we are going to do is we are going to transform all of this code and we are going to use a state pattern to solve all the issues of extending this code and making changes to it. So let's get started with that.
So let's start with the conversion of our player controller to use state pattern so that we have separation of logic, clear lifecycle methods, improved organization, and better handling or debugging of our code. So let's get started. So for that, I'm going to create a new script, create a new C# script, and let's call this our player state. Now this player state is going to be our abstract class that will have all the states of the player. So this is going to be our abstract class, basically the abstract implementation. And inside this class, what we need is access to our player controller. Then we need access to the rigid body, since we are going to use that for the jump and other physics-based calculations. We need access to the animator. Next, we need to create a constructor of the public player state, and this constructor will only take the player controller. Then inside the constructor we'll get the player controller, then we'll get the rigid body, and finally we'll get the animator. Now let's create abstract implementations for our states. So public abstract, what we have our enter method, meaning when we enter this state, what will happen. Then we will have another one for handling the input, then another one for our logic update, and another abstract implementation would be our physics update, and finally what will happen when we exit the state. So this is our abstract state, which is the player state, and inside this we created the different states or the different abstract implementations which our player controller or our player or a game object will have. Now let's create each state. We can create each of these states in a different script. For the sake of simplicity, I'll create the classes here. So our first state is going to be the idle state. And how do we create this? Really simple. We just do a public class, and this is going to be our idle state, and it will extend the player state. Now the player state has some abstract implementations which we need to implement. So first of all, we'll basically generate the constructor for our idle state, which takes in the player controller. Since this extends the player state, we'll call the base constructor with the player controller. And after creating the constructor, the next method we need to override is going to be our public override enter method, and inside this we are going to basically play our idle animation. So animator dot play player dot idle state hash. Let's see what's the name in the player controller. Okay, this is private. Let's make this public. Let's make all of these public, and this is going to be our idle state hash. Idle state hash. After playing our idle animation, we are going to reset our velocity. Velocity equals vector 3.0. And next, what will happen when we receive some input? We will write that functionality in our public override handle input function, and we'll say that input dot get axis horizontal is not equal to 0. So let's just add an if condition here. If it's not equal to 0, meaning we are pressing down some button, then we will change our state to the player dot jumping state. Currently we don't have the jumping state or the change state method, but we are going to create that, and this is going to be part of our player controller. let's quickly update our player controller. Since our player controller will not have any functionality, so let's update the player controller and I'll show you the class after updating it. So here I have updated the player controller, and we have removed all the functionality that was basically implementing the different states like jump, movement, falling down, and all of these are now going to be handled by the state classes. Currently we only have one state, which is the idle state. That's why we are getting these errors. But let's look at the code. So when the player controller is enabled, we'll enter the current state, which is set over here, the current state, and by default our current state is going to be the idle state. So when we start the game, we will enter the idle state. We have the update method, which basically checks for input and logic updates. Then in the fixed update, we check for any physics based updates, and if we call a change state method, it will call the exit on the current state and the enter on the new state. And here we have a simple is grounded function from the previous code. So now let's continue the implementation of our states. Currently we only have the idle state, and let's handle the input for this. We also need to check if our input dot get key code dot space and our player is grounded, then we will change the state to our jumping state, player dot jumping state. And we made a mistake here, this should be our running state. Okay, so we have handled the input, we have handled when we enter this state. Now let's handle the logic update for this state. So this state only needs to check that if we are grounded or not. So we will override logic update and simply say that player dot check grounded. Check grounded is a really simple function which simply casts raycast into downward direction, and if it hits the ground layer, this becomes true. This is all it does. And since we are not doing any type of physics updates, we'll just keep the physics update empty. Same is the case for our exit method. Override exit, we are not doing anything in the exit as well. So here we have created a simple idle state, and as you can see, our idle state behavior is now encapsulated within this class only. If there is any problem with our idle state, we'll only look at this class and ignore any other states. Similarly, we can create other states and write the same code which we had previously in the player controller in these states. So let me create the running state quickly. So for the running state, we are going to create a new class, public class running state. It extends the player state. We need to create the constructor. After creating the constructor, we need to write our enter method, and inside the enter method we are simply going to play the running animation, which is the player.run to hash run state hash. And then for the input, let's public override handle input. In the inside input we get the horizontal input, and let's create a class variable here, private horizontal input, and here we'll simply say horizontal input is equal to input dot get axis horizontal, and if it's not equal to 0, if the horizontal input is not equal to 0, means we are moving. First let's check the 0 means we are idle. It's simpler that way. Player dot change state to player dot idle state, and else if we press the jump key, which is input, let's just copy this instead of writing it again. If we press the jump key, we'll simply go to the jumping state. And inside our logic update, public override logic update, what we are going to do is we are going to check, basically we are going to flip our sprite, because that was the only thing our logic update was doing in the old code. So if the horizontal input is greater than 0, meaning we are moving towards the right direction, then we'll set the player dot transform dot local scale to 111. Else if the horizontal input is less than 0, we'll flip it. And finally we'll check if the player dot check grounded, if we are grounded or not. And in the physics update, we are going to apply our velocity. So public override physics update, and here we'll say the rigid body dot velocity equals new vector 2 into horizontal input multiply our player dot move speed, and our y velocity, since we are creating a 2D project, we don't need the vector 3, we will use vector 2, and we don't need to do anything in our exit method. So override exit, and this is going to be empty. So this is our running state. So we have created two states, our idle state and running state. Similarly, we can create the other states in a similar fashion. So I'm going to do that quickly and show the states to you and explain what these are doing. So I have added the other states. So this is our jump state, which extends the player state, and here we have our horizontal input and our jump time for how long will we jump. We have an empty constructor, and in the enter method we simply change our animation state to the jump state. We add a force in the upward direction, we start the jump time, and we set the is grounded to false since we started jumping. And in the handle input we'll check for if we have any horizontal movement. Then in the logic update, if the horizontal movement is greater than 0 or less than 0, we simply flip the sprite similar to how we did in the running state. And here we check if our jump time is greater than the minimum duration, we will reverse the velocity, meaning the player will start falling now. And finally we'll check if he's grounded, then we'll change to the idle state, and if he's grounded and our horizontal input is not equal to 0, we'll change to the running state. And in the physics update, it's really simple, we don't have to do a lot, we just apply a linear velocity to the player when he's in the air, and we apply a small amount, basically a factor that will reduce the linear velocity in the air, making it hard to control the player. And in exit we don't need anything. And similarly the falling state is very similar to the jump state. We just change to the falling state, we handle the horizontal input. In the logic update we flip the sprites, we check if the player is grounded. If he is grounded and the horizontal input is not equal to 0, we change to the running state, and if it's equal to 0, we just change to the idle state. And the physics update, we apply the same velocity as we did in the jumping state, and the exit is empty because we don't have anything for the falling state. So all of our logic are handled by each of these individual states, and in our player controller what we do is we create some public variables, some private variables, we hash the animations, and finally in the update when we on enable we enter this current state, which is the idle state by default, and in the update we call the update and the logic update of the current state, whichever state we are in, and the physics fixed update we call the physics update of each state. And in the change state we just change our state by passing in the new state, call the exit on the current state, and the enter on the new state. And this check grounded basically checks if we are on the ground or not. So we have successfully converted our old code into using the state pattern, and by using that we have improved our code organization. We have separation of logic, meaning our player controller only controls the state, it doesn't do anything else, and each state is responsible for its own behavior. So each state has a separate logic in its own class, and it's really easy to extend these. For instance, if I want to add a new state called wall sliding, I just create a new class like this and add the functionality to it. So this code basically follows the clean code principles, and it's really easy to debug and test. So let's test our code and see if it's working as we want it to. So if I select my Ninja, it should have the player controller on it. It has all the different values assigned, and if I hit play button, by default I should be in the idle state. Okay, we made an error. Instead of using rigid body 2D, I think we accidentally used rigid body. Yes, this should be rigid body 2D, and we'll get an error over here because we need to use force mode impulse 2D. Force mode 2D dot impulse, and I think that's the only error we have. Let's see. Oh, this should also be rigid body 2D. Okay, now let's test again. So by default we will be in the idle state. Left right will make the player move left right, space would make the player jump, and after reaching a certain height it will fall down, and I can move a little bit in the air while jumping. And if I jump and hold down the movement keys, I change to the movement state, and if I don't hold down any key, I change to the idle state. So our code is working perfectly. I hope you guys enjoyed this video, and I'll see you in the next one.